Hello and welcome to the first of our 10-minute tutors. We talked about this in some of my IT management videos on what does an IT manager need to know. And we said you don't have to be experts on everything, but you should have a good understanding of what a tool does and context when to use it. So first we'll talk about what SQL really is. SQL or SQL is a language. It stands for Structured Query Language. And what it is it's a language to insert, update, delete, access, select information from what's called a relational database. And the interesting thing to me is how many people I've run across, managers that don't really understand what it is because they've never really worked in it. And the best way to think about what SQL or a SQL database is or a relational database is to picture a spreadsheet. And you have a spreadsheet of customers, let's say, that buy something from you. And every time this customer makes a transaction, you don't want to have to put in the customer's first name, last name, or if it's a B2B thing. We do a lot of work with big retailers. So every time we made an order for Walmart, we don't want to put, this is Walmart, this is the number of the store, this is the address, this is the manager, this is the contact information. So what SQL allows you to do, or a relational database allows you to do, is have a customer table that maybe just has an ID in it and the name of the customer. And then you have a contacts, another like spreadsheet, which is another table. And that spreadsheet would have that customer ID from the first table in it. That will be called a foreign key. The primary key was on the customer table. The foreign key is on the address table, and it points back to the original customer table. So that way, every time we make an order, we don't have to put the name and the address. And what's really cool is we don't even have to put the name. So when the order comes in, it comes in through what's called EDI, and it will give us what the person or what the store bought, the quantity that they bought, and maybe the price they paid for it. So then that can relate to what's called a product table. So you just all you have to do is have an ID of the product. And so now your insert is just a store ID, a product ID, the quantity they bought, and maybe the price and the date. Very little bit of data inserted very quickly. And it expands to a lot of different things that you don't have to duplicate every time. So if you hear that term SQL, a lot of times you'll hear T-SQL, which is Microsoft's interpretation of the structured query language, PL/SQL, which is Oracle's, there's PostgreSQL, MySQL, DB2. There's a lot of different implementations of SQL, but it's all supposed to kind of use the standard same language. And it is super efficient, like I said, for putting in what's called transactional data, sales data, demographic data, things like that, that are sometimes slowly changing, sometimes quickly changing. But the biggest takeaway you should get from this is the reason you want SQL and high transaction data is so that you don't have duplicate data all over the place. It's very much efficient, not in just storing the data, but inserting the data and selecting the data. And over the years, SQL evolved to be not just what's called OLTP, online transactional processing. Those are those sales. Now you can do, and you've been able to do this for 20 years, 30 years now, is OLAP, and that's online analytical processing, and that is what a data warehouse does. So you take your SQL database and we'll get into data warehouses more in another video, but you can aggregate that data. So if you don't want to look at the data, let's say your sales are in there by hour or by day, you probably don't want to look at it even daily. In most cases, you want to aggregate it and say, what was the sales for this store per week? So you can aggregate that data and sum it all up per week. And then you have less data. And then what's really funny is, and a lot of people struggle with, is you deduplicate it. Because you just want your report writers, Power BI or Tableau, these people go out and get this data, and this SQL data, and they pull it down into a report. Well, you don't want them to have to do a ton of joins, so you take that SQL data and you put back the address maybe, but you can be very selective on what you put in there, and at the end of it, the date is maybe a week, and the sales are the summation, the aggregation of sales for that week. SQL is really good at all of these things. And it's when I first started programming back in the late 80s, it was I wrote a program that tracked all of the hardware we had at the design engineering department of General Electric. Well, we didn't have relational database that time, so we had access to a mainframe. It was in a program called IBM Focus, and it was just a flat file database. So every person I put in there, John Smith has an IBM 486 computer at location A27. He received it on this day. The next line was John Smith at this same location also has this HP LaserJet printer that he got on this date. So I had a lot of duplication of data. And God forbid if John Smith married Mary Jones, right? Because her last name would change to Mary Smith now. Well, there would be maybe 40 records in there that all had to be updated. SQL stops you from having to do that. You only have to update one record. And in that location of the printer she had was attached not to Mary Smith, but to a table with a name Mary Smith in it with the ID of 7. So the ID of 7 didn't change, just her name. Where this happens every day for SQL people is people move, their addresses change. Imagine if you had that list of this person had bought 5,000 items from you over a 10, 20-year period, and you had to change 5,000 records. Incredibly inefficient. Relational databases and SQL transaction processing makes this all really, really efficient. And it has another benefit to insert, because you're only inserting or changing things once. It stores much less data. So in 25 years ago, hard drives were really expensive, so that was a big driver. So that's kind of SQL in a nutshell. And what you should think of is just an Excel spreadsheet and another Excel spreadsheet and another Excel spreadsheet, but they're all kind of related to each other. That's the simplest way I could put it. And the way to use these videos is now you understand kind of what SQL is and when it should be used. When you're storing a lot of data that's kind of structured and needs to be inserted quickly or updated often, SQL is the way to go. As we get into other things like data lakes, data lakehouses, you'll see that that is unstructured data. There's no good way to relate the things together, especially when you first put it in. So you put it in there so people can have access to it, and then if need be, you can structure it for use later. Hope you like this. We got a bunch of them to do. There's a lot to go on. If the primary part of your team on these videos does something that's covered on these videos, these are just 10-minute quickies. So what you do here is you take this, okay, I kind of got where it is, and then either read more or try to watch like a 1-hour video on an introduction to SQL if you want to get a little bit more hands-on to it. What I like to do also is Terraform's really big right now, and I really didn't want to become a Terraform engineer. I might manage a Terraform engineer, but I don't want to be an expert on it, and we'll get into that one as well. But so I watched a 10-minute video. I kind of knew what it does. I want to get a little more in depth into it. And then I took it a step further. I watched over a period of a couple days. There was a really good intro video, and I might link when I do that one. It was about 90 minutes so that I had better context. I knew what Terraform does, but better context. That's a good idea too. The deeper you have to get into it, just spend a little more time. I retain things better. If it's an hour video, I'm better watching 3 20-minute segments of it. I do better learning from recall over a period of days, 2 or 3 days, maybe even a week. Hope you like this. If there's a specific thing you want to learn, put it in the comments. Or if it's there's one coming up that's probably going to be covered, because we're going to cover DevOps, a lot of the basics, just subscribe and you should be notified when those come out. Thanks for watching.